Okay, welcome back after the break. Please welcome on the stage this brave woman from Kiev, Ukraine, Kateryna Hrytsaienko.
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 It was close.
Close one. She's a tech woman, Techmakers ambassador, and today she'll tell you about creating ML pipelines. Big applause for Kateryna.
Thank you, everyone. Thank you so much for choosing me over food. I'm really flattered to see so many people here, especially because I'm extremely happy to talk about MLOps, because this talk is based on my own tears, pain, and blood. So you will see later why and how come, and let's do some amazing stuff together with all of you. So actually, I want us to shake some sleepy time from lunch, and I want you to please do some small activity for me. Please raise your hand if you work with ML, data science, something from the domain. Okay, I see hands. Okay, and if you ever try to run some ML models on your machine, just to try, like, you know. Ah, I see, yeah, nice. And who knows about something about Ray? Nobody. Oh my God, perfect audience. Yes, it's amazing. There would be no person like, it's not quite correct. Okay, let's then start with our presentation. And firstly, nice for introductions. This was so amazing. So one additional thing. I work with Google developer groups, so all I will show you today would be connected with Google, and I will show it on Google Stack. But if you want it, you always can migrate it, because we are doing what? We are doing Kubernetes, of course, and you can do whenever you want in any cloud, basically in any tools. So just for giving some background, I work with platform teams. I work also in Java development, but my main passion right now it's NLP pipelines, and I do it a lot for our Ukrainian community within the, also corporate jobs, and that's how I realized that we have huge problem with MLOps. We have really huge problem, dear people. So here it is our agenda. We have a huge list for today. So if you notice that I'm going into Eminem mode, that's for sure, because I try to show you basically everything, every detail, every important thing that you should know to start your first MLOps pipeline. So the main idea is that after this talk, you have all the information you need to go and start your first MLOps pipeline, even from scratch. And also I want to show you that if you already know DevOps, and we all probably know DevOps here, you are quite equipped to start your first MLOps pipeline, and you don't need to invent a wheel, go to some expensive tools like Vertex, etc., and other competitors. You can do it with plain Kubernetes and all good news. So let's start with it. So basically, when I told you that it's based on my own pain, that's a true life story. So that's my team basically, and me on the other side. So we wanted to do some huge NLP pipeline for our university and for making the RAG in Ukrainian language with some additional pitfalls and perks. And we realized that we need to evolve our model, because our model should be changed over time, and we also need to deploy it. And when we came to conclusions that nobody, for some reason, in commerce world tells you about how to do your first MLOps pipeline easily, we decided to actually create something on our side. So that's where the talks come out, and this talk is mainly targeted on DevOps audience, because I will do most everything with Kubernetes, so keep up with it. Basically, what we know about Kubernetes and about MLOps within the Kubernetes. First thing that we know about MLOps, that it's what? It's complex. Everybody talks that MLOps, it's something like DevOps, but not quite. And we are having a lot of holy wars, because we still not decided what DevOps is, and when MLOps came, we are just like, oh, another term to define. And actually here you can see quite nice example of how people usually imagine MLOps. So that's basically the picture to get you scared a bit. That's a picture from the Google Cloud documentation, and if it works for Google, probably it could work for us, but we have much less money than them, so we need to probably adjust a little bit. So what they say that probably we should have some source code within the MLOps, of course, because we are doing our model. We have some CI/CD, we have CD, perfectly, we will do some deployment, and then you see this strange arrow that goes to the huge thing, and there is something about data, about preparation, about model training. So on this moment, usually you see it, and it's quite logical, so we know that our model should evolve, it should grow, and we should change the data, but how the hell we should do it? Like, we know how to do CD, we know how to do CI, probably we know how to do testing properly and monitoring, but what we should do with the continuous training at all? I actually have a pretty nice picture for that. So let's firstly define what components are within the MLOps and what you need to know before you start. First of all, there is a lot of parts. First is data that I already told you. We need a lot of data. They need to be different. They need to be good quality. We will do some nice tagging, nice labels, and etc., etc. So IDA is extremely important within the MLOps and in general in the ML community and models when you prepare something nice. Also, we have training and tuning. That's obvious. We need to adjust our model within the time, so it's kind of okay-ish. Also, we have pretty similar and nice to real-world commerce application review and governance. Of course, we just have different criteria there. Interface and serving, that's where our model is actually up and running in some nice and quite cool clouds. And last but not least, we also have monitoring how our program performs, how our model performs, and do we really meet our customers' criteria. So that's basically how MLOps in a nutshell look like. Let's reorganize it and think about it from perspective what we actually know as advanced DevOps engineers. So what we know about these steps. Firstly, we know about CI/CD. We all know how to do it. We know how to do it with containers. We know how to manage it, etc., etc. But there is some new parts for us as well. So here is continuous training that I already told you about. That's the moment when we need to retrain our program and our model to be actually usable in future with new data. Also, we have IDA. And we have monitoring. So it kind of looks like we have CI/CD and we have monitoring and we kind of sure that we know what to do with it. So only new part for us is IDA and CT. So let's explore it, let's check it out, and let's understand what challenges do we have within these two specific steps. So basically, what we have in IDA, our main problem with IDA is that data is huge. So there is a lot of data that we need to process. We need to follow up with the quality of data. Somehow, we need to each time check the data is good enough, and we cannot just put some student who sits there and checks if the data is good or not. Preferably, we need to automate it somehow so we can reuse it later. So that's the first thing about data. Secondly, how do we put data inside of our training? So, you know, in different clouds, in different systems, whenever you're using the huge amount of data, how you would stream it inside of your training pipeline. So this all comes with cost, and we need to think about how to optimize this the best. So main problem with data is a huge cost, huge amount, and how to optimize it properly and properly prepare it. Because we cannot just find a couple of different data sets on the Kaggle and say like, now your model should learn from it. Because of course data comes in different formats, different providers give us data, so we still need to work with it a lot. About continuous training, the same problem. Problems that we, first of all, we don't want to train our program all the time, to train our model all the time. So we need some quiet times when we don't use any resources. So the hugest problem with continuous training is that we need some efficient way to publish our resources and get them away as quick as possible, preferably to zero. So we want to, some whenever mechanisms that we will do for training, we will just put it in the clouds and hopefully delete it as soon as the training is done, and we can get back our resources and back our money. And actually continuous training also needs to be done on the quality basis, so we need to check it from the time. For example, when the data changed, when we have some new requirements, and etc., etc. So continuous training will be done quite often. And you would say, Kate, but you haven't said anything about monitoring, and it's suspicious because it's on slide and you don't talk about it this much. Well, because not all doors we can open at once. Monitoring looks like something similar that we do in our common commerce application, but in ML, that's a huge stuff under the waters for monitoring. Because you don't only need to monitor your health check. If your app is running, nobody cares actually about this. It's nice that your app is running, but is your model actually working? So we had a lot of huge complex concepts like data drift, we have concept drift, we have quality drift, and don't even get me started on that. So basically, just really quickly, when we do data drift, that's when our data is coming new. Concept drift, it's when we have the new pattern that doesn't match our previous activities. The simplest way is when we had the COVID that hit us and all the traveling went down because we had completely new patterns in how people travel, how people buy tickets, and etc., etc. So all your fancy models, all that you trained for so long now doesn't work at all because you had some global change and you need to somehow to adapt to it. So that's why there is a huge amount of different AIs that would help you to do the monitoring. But unfortunately, it's not topic for today, so I would suggest for you, if you allow me, of course, to completely drop monitoring from our continuous training pipeline, because otherwise we will need to talk for hours and explore the concept of data drift, quality drift, and etc., etc. But you need to remember about this. So if you want to ever go in production with your ML model, this is exactly what is waiting for you in the future. So you need to be really careful when you come into the monitoring tokens. But there is one more door that we need to open still. So basically, we know that we are versioning our APIs, we are versioning our commerce application, and etc., etc. And in a similar way, we need to actually version our models. But models are tricky. They versioned in a different way than our actual applications. And I think my microphone is running away from me. So basically, what is in with our nice and cool models? First of all, we change in the version of our models when we change in the parameters inside of it, when we change in weights, when we change in our data. That also applies to our model. Not only code inside of your model is important, but also how you train it. So that's additional metadata that you need to store. So basically, how the versioning in terms of the models look like, you have some metadata that usually complies with training parameters, with some data for the weights that you used for concrete model training. Also, sometimes it's performance. So we usually measure the performance of the model and then put it inside of metadata. And actually, if you look on this like that, doesn't it remind you something like at least a little bit? So it's actually, we can treat the model versioning quite similar as we version our containers. And actually, in scope of my talk, I would suggest to you, as we would use Docker as a main source for actually holding our program, I would suggest to use a Docker image registry for using the versioning and doing the proper versioning for your model. Of course, you can do something fancy with MLflow, of course. That's another term that you should remember if you want to do production stuff. But Docker image is quite enough, and versioning from a Docker image is quite enough to start with putting custom labels, custom tracks, and keeping the information about your nice and easy model registry training. Why I'm telling about model registry at all? Because we have our technical task. So we came here to see MLOps pipeline. So that's why I was needed to tell you all this information in beforehand. So basically, the good technical task is 90% of the success. So what we want to build today? We want to build some pipeline that allows us to retrain our model in some trigger. It could be new data loaded in your storage in some cloud. It could be manual trigger. It could be reaction of some manual value of the metric, and etc., etc. We want to trigger the retraining pipeline. We want to fetch data from somewhere, and we want to put it in the model registry and latest service somewhere. So that's pretty basic and nice technical task that we want to accomplish today. So let's see what we are doing here. Basically, that's my favorite slide because now we go into the tech terms. So that calls explain for the stack. And basically, what I suggest to use as DevOps that you want to start with MLOps stuff, I would suggest to use Kubernetes. I would suggest you to use Docker registry, and I would suggest to use Ray. Probably only thing that you don't know on the slide is RAID. And let's check out firstly Kubernetes, because we are all also for here. So why I suggest to use Kubernetes and not some fancy tool, for example, like Vertex AI that Google has, that advertised as one of the best tools for actually deploying your model. The thing is that Vertex AI, it's awesome, but Kubernetes, in its nature, is fitting for our MLOps pipelines. Because imagine we had a problem with making our infrastructure scale and then scale to zero. That's Kubernetes can do for us. We have awesome ecosystem within Kubernetes, and we all know what to do with containers. And we all know how Kubernetes works, so we can actually, with lower threshold, start working with MLOps pipeline. So I suggest to you to not learn firstly the Vertex AI and complex system within Vertex AI in a nutshell, but actually use what you already know and proceed with it further. And to make a way of integrating with Kubernetes smooth, we have Ray. So Ray is another open source project. Unfortunately, they don't pay me, but I hope one day they would, because I love it so much. It's one of the rock stars in the world of ML domain at all. So basically, what is Ray? Ray is evolutional thing that allows you to manage low-level dependencies, low-level processes with high Python API. So imagine that. You can manage something so low level as amount of GPUs you're using and amount of the space on the disk that you are using with Python. That sounds something like maybe a bad idea sometimes, but actually it works perfectly. So what Ray does? Ray allows you to manage the low-level processes, and they have a lot of different libraries that allow you to proceed with different parts and different moments of life cycle of your ML model. So basically, what Ray do, Ray provides a Ray core. That's a huge library that works directly with your cloud provider. Then it has a lot of other libraries that you don't need to implement. So if you wanna, you can use only Ray core and don't get stuff about the Ray libraries at all. But probably you will want to use it because they are covering hosting, training, tuning, and also IDA as well. So Ray have everything basically that you need to have to start a MLOps pipeline. Let's see what is happening inside. So basically, Ray core is most important thing for us because, as you probably know, our huge and complex ML systems usually have too complex operation to have it on one machine. So nobody actually talks about running MLOps pipeline on one GPU, because otherwise it would be a joke. If you want to run it for 1,000 years, please feel free to use one GPU forever you want. So the problem is when you have a distributed computer, you need to also care about how your training proceeds, how your concurrency works, how your database reacts, and etc., etc. So that's also job of the Ray to handle for you all the distributed processes. So Ray takes this burden from you and throws this away. You can completely focus on development, on hosting, on management, on doing MLOps, but you don't need to carry any more issues with distributed process. How it works? And actually, it works pretty easy with Python. And when I'm talking how easy it is, you will see it in a minute. Because, you know, like, different people say different things about easy parts. So easy could be easy like 1 point easy, and easy could be 10 points easy. So let's see and check out what actually Ray does. Furthermore, Ray allows you to have this high-level interface with Python, and when I mean that it's easy to integrate Ray in your already existing Python code, only thing that you need to do to make your computing distributed with Ray, it's to add the annotation. So basically, that's all that Ray requires from you as, for example, developer to put the actual distributing processes within your system. Ray works as a wrapper. So it creates around your model wrapper that gives you opportunity to do distributed processing. So basically, you can see the example for function and class that we can run on multiple machines at once. We can run it in multiple threads, and etc., with just adding the annotation and then calling it appropriately from different parts of your program. And even more, when I say that we can edit some really low-level configuration with Ray, I mean that you can define how much of GPUs you want. You can define how much of CPUs you want to run your actual application on, run completely on this actor, for example. And even more importantly, that you can define the options. For example, in the case below, I think I have the example here that if you want, you can define that your class will run on 2 GPUs, but otherwise on 4 CPUs. And Ray will find available tools, available machines for that, and they will put it in progress so we can run our cluster, we can run our application simultaneously. So that's kind of amazing, actually. I don't think we are able to do something like that with any other framework yet and do it so easily and nicely. But the main problem here is that you need to be really careful if you are stepping to this road, because Ray is smart enough to know that you not always have this amount of GPUs or CPUs, so if there would be no available resources, Ray would do nothing. But also there is amazing talk from the last Ray Summit at 2025 Ray, where they showed how you actually can also optimize the CPU and GPU usage with percentage. So it's not only even numbers that you can add here, but you can say, for example, this function requires 0.75% of the GPU, and Ray will handle that for you. So that's the job that Ray does for you. The second thing that we have, it's Ray data. I also have the QR code that I encourage you to check out, because that's awesome example of how Ray data works in the Pinterest, so they're using it already. Basically, what Ray data does, it's allow you to produce some awesome ADA pipelines for processing your data and information, but most important for us, what Ray data does, it allows you to stream your data from the patches and easily to manipulate your different batches of the Ray data in general. So we're not working with a huge data set, we're working only with parts of it, and then we process it in the Ray train job. So that's high level, basically how Ray data works all together. And the last, in the terms of training, but not least, it's actually Ray train. That's our powerful engine. So basically what Ray training does, it integrates first of all with a lot of different engines like Hugging Face and etc. etc. You can use your train functions that you already have in the training engine, for example, and then Ray under the hood will split up your training process in a couple of workers and do it simultaneously for you as well. So you choose the train function, you choose the engine, and then all the under hood work Ray does for you. And actually that sounds kinda awesome, that you don't need to do it at all in the nutshell by yourself. And last but not least, that's actually where we have hosting. We have also Ray serve. And it's again, I'm just enjoying how simple it is, because to make Ray working and holding your application together, we just need to annotate our nice and easy code with serve deployment annotation, and that's all. Now Ray knows that it should pick up your awesome class and work with it later, so it will be published and hosted on some proper model. So basically, Ray is like magic wood in all the terms when it comes to the MLOps in general. But probably you're sitting and wondering, like, okay, we have Ray, we have distributed processing, somehow it doesn't feel right, because Python, low-level processes, and Kubernetes, something doesn't match. So we have some missing point here, and we need to find out which exactly point is missing. And thanks to God, we already have open source tool for that. Somebody created it for us. There is an answer. There is operator that calls KubeRay that allows you to manage Ray within the Kubernetes together. So you have list of custom resources that will allow you to integrate your Kubernetes into the Ray seamlessly and quite easy. You know what I like about this operator? That it has only 3 resources, like 3 custom resources that you can use, and that's enough for you to start. So basically, KubeRay, it's an operator. Through each, we can do scaling requests, health checks, create pods, delete pods, and etc. So it will be our middleman between our high Python functionality and our awesome Kubernetes. That's exactly what it does. And we have 3 types of resources. We have Ray cluster, Ray service, and Ray job. What is different about them? Well, Ray cluster is actually a huge container that will hold everything together. So that's where Ray do its like core configurations. Ray allows here to manage your distributed processing. Everything happens in Ray cluster. So that's a huge thing that allows you to actually run your Ray application. Then we have Ray service. Ray service is Ray cluster plus Ray serve. So it basically means that it's a huge container with your model inside. That's exactly what it does. And the third but not least, it's our Ray job, and that's where things start to get amazing. Because Ray job could be run within the Ray cluster, and what it does, under the hood, it triggers the Ray processing, and then completely cleans up the resources after the Ray training job is finished. So you don't need to care at all how it will be deleted later, because whenever the Ray training is done, job will be cleaning up itself. It could be dangerous if you are using some shared resources. You need to be always aware that Ray job will clean itself up, but that's quite nice functionality to scale to 0, and that's exactly where we benefit from losing less money within the Ray in general. And now we have some easy slide. It's actually a health check slide, because I want to see in your eyes who made like this, because it means that you're actually listening to me and you're checking out what I'm doing. I see some people who made this face. So basically, we talked quite a lot already. It was a long journey so far, so let's just remind ourselves why we are here and what we are talking about. So we are here to surprise design MLOps pipeline. Remember that we want some trigger, we want some training, we want some model registry, some information how we should train our model, and application that should be served. And that's exactly the architecture that I'm suggesting to you. Actually, don't worry, I have a full run book on how you can implement this, and I will share with you later so you can do it on yourself at home. And also important to know that I plan to have some Google credits for that. So in future, just check out the page from time to time because I'm adding the Google credentials that you can use, so you can also use some additional money for testing it all yourself because it can become a bit expensive when we are talking about big models. So coming back to our suggestion, what I suggest you to do. So imagine that we have our amazing models that we want to publish. What I suggest you to do, I suggest you use Google Scheduler under the hood to produce events for PubSub. That's basically a huge event manager inside of Google that will allow us to actually trigger some pipeline. Under the hood, I suggest you use some cloud functionality for serverless approach to trigger our pipelines. Why? Because in future, if you want to make monitoring, that's exactly the place where you will do monitoring health checks. So basically, under the hood, how it should work, we should, from time to time, trigger the event to have cloud functions that in future will trigger our monitoring processes, but for now, we'll only do the training application. After that, we will fetch data from some provider inside of Google, because I like Google and I work a lot with it, so we're going to take it BigQuery. And under the hood, we will use a GKE automatic manager that will allow us to scale and scale on run. So that's one of the easiest architectures that you can do and manage to start your first MLOps pipeline ever. Actually, here you can see MLflow or the Docker image registry, whenever you would prefer. If you want to start with hardcore, I recommend you to do MLflow, but otherwise you can start with just Docker images. And here you can ask me, well, I see a lot of stuff, Kateryna. I see like a lot of different services that work in for us to make MLOps pipeline, and you may question me like, how is this easier? How is this cheaper, and how is this better in a nutshell? Well, if you want to use some Vertex CI tool to make your first MLOps pipeline, or any competitor, just trust me, you will still need to do this. So you will still need to do some automatic scheduling, you will still need to configure some PubSub, some triggers, some managers, and etc., etc. So seamlessly, architecture around will be the same, you will just use different engine. Instead of the Kubernetes and Ray, you will use under the hood Vertex CI. And plus of that, also because I'm a bus killer, I counted the costs for spending money on your custom training with the Ray and with the Vertex CI training. And as you see, we have much cheaper version with the Ray. And this one is counted for 5 hours a day, 20 days in month with serving the stable diffusion model. So that's how it works. Actually, my stable diffusion model is a bit cheatering because you see it's quite small. I have a low amount of the nodes that I'm running it on, but still the amount of money that you can economize with that is quite huge. And the last but not least comment why you should use maybe Ray and Kubernetes, because under the hood, that's exactly what Google does. So maybe they're not using Ray explicitly, but under the hood, Vertex CI works with GKE, and we are doing the same stuff, but you are paying for less difficult approach when actually you as DevOps engineer, you can easily learn about Kubernetes, you can easily go and do extremely simple operations with Ray in the end, because you just need to add one annotation and you can spend much more less money and understand your system better. And also one important argument, whenever if somebody tried Vertex CI, have somebody tried Vertex CI? No? Yeah. So you probably know that we still have some issues when you want to customize your behavior too much. So there is like huge problems with how you are customizing the behavior under the hood of Vertex CI, training, etc. Here, with GKE, you have complete freedom. Do whenever you want. Ray allows you to put your models in a row. It allows you to create multiple pipelines. It allows you to even do versioning within the different models. You can support different versions of models in the same application. So amount of stuff that you can actually build with Ray under the hood is amazing. And I highly recommend you to spend few nights in your evening with checking out my cookbook, because it already has all information. So you don't need to go and search it all by yourself. You can already use it and check out. I also will have a form there, so please please keep the updates because I want to share with you the Google Credits so you can start working on the labs as well. And I will be also really happy to connect with you on my LinkedIn because if you have some additional questions and we won't have time for that, probably or not, you can ask me there. I'm usually quite responsive. Yeah, so that's it from my side. Thank you for your attention. It was sweet.
We still have 5 minutes if there are any questions. So
I see some questions. Awesome. Actually, I was so worried that I will be too much information that you won't have time for questions, so I'm happy.
Yeah, so you mentioned that we can use our own. You mentioned that we can use our own cluster to do it. So with Ray operator,
Yes.
does Ray operator is using the dynamic resource allocation API for?
I think yes, we can double check that, but I'm positive in the documentation you can double check it right now, or I can check and tell you later. But my first answer is yes. Yes. And it's also open source.
Thank you for your speak. I have a question regarding the managing resources, because I see that Ray, as you say, that we can set how many CPU memories we can set for specific process. How it communicate with Kube scheduler?
So that's exactly the job of the KubeRay that we are have as a middleman in between. So Ray communicates through the API within the KubeRay, and then KubeRay translates our request to the Kubernetes itself. So that's exactly the job of KubeRay that it does. If you want to use it, you can, in Google, it's easy because they already have Ray operator pre-installed on your GKE if you choose this option. But if you want to use something different like AWS, you can just download the open source KubeRay and just raise it on whenever cloud you want. But that's exactly KubeRay who manages all these queries from Ray and this underhood processing to the Kubernetes, so they will work together and not against each other. Okay.
do we have any more questions?
I see only some sad faces like, should I do it at home or no? I'm not sure.
If no, then thank you again, Kateryna. Now we have a short coffee break, and please be back in 13 minutes. Big applause again for Kateryna.
Oh, thank you so much. Thank you for having me.